Alrighty. Well, welcome back. So before the break, what we had done is we'd actually gone through and looked at how we can take shapefiles and use ChatGPT to actually create boundary information and be able to basically make maps of things that you can load as HTML files, which I have to say I really like. I'm always a huge fan of this capability of being able to make HTML maps because for me, if I want to make a quick report, this just lets me like pull this, boom, screen grab it, throw it in a report. No fuss, no mess. But what our goal here, of course, is to replicate this capability in AutoCAD to actually be able to calculate elevations of the two different surfaces. And we've got these two LAS files that represent two different periods of time of a construction site project, and we want to calculate how much volume was moved. So let's see how we're actually going to approach that. So the first thing that we've always got to do is we've got to figure out how are we going to actually frame this question, right? So we've got a LAS file. So LAS file is that point cloud. That's a binary file. Yeah. It's not just an easy text file that you can open and read. We've got the shape file, which is the boundary of the area we want to calculate the volumes between. That's also a binary file, so you can't really it's not a text file that you can read. So I've got all these files that I'm not necessarily sure that ChatGPT is going to be able to handle. So we found it could read the shape file, but let's start seeing what happens with the as files. So I'll start off with, I've started a new chat, and I'm going to say, I have two surfaces. Actually, let's start with one. So I'm going to say, I have a surface for a site that has been captured using LiDAR. Can you read this LAS file? Right? A handy way to start these things is just by saying, hey, can you actually even read this? So we're going to drag and drop that whole file. We're going to say, boom. And again, if we click that Analyzing tab, this is what it's attempting to do. Looks like it's trying to kick off some sort of routine involving LASPy, which would be a Python routine to read LAS files. But it says, hey, I actually don't have that file available to it. So it says, that's interesting. You could use Cloud Compare, LAS Tools, QGIS, etc., etc. I'm just going to throw it. I notice it doesn't mention Solve Engine. It really should. So the learning is not. So shout out to SDAI there. But anyways, okay. So we can't actually do this using straight LAS. Now you've been kind enough to actually provide all this data as a XYZ file of points, where all the points are just their easting, northing height, I guess is what that's happening there. And we've got a ton of these points, so we're going to say, okay, that's all right.
Do better.
Yeah, I'll upload a coordinate file. Can you read this file? And what we're going to do is we're going to go and drag and drop the 2006. And you've also been kind enough to post this at a 2-meter spacing, just so that it's a bit shorter in this file. I'm going to give it a break here. Alright, so it's reading, use commas and a delimiter. Okay, reload it using, so it's figured that out, so that's handy. And it's figured out X, Y, Z. Great. Do you want to create a surface plot or elevation map, filter or sample the data, calculate terrains? I'm curious if you can make a call. Yeah, okay. Yeah. Yes, please make a contour map. Yeah, let's see what happens. Why not? Contour.
The flat. This is kind of enough.
If I could spell contour. See, one thing I also notice is that ChatGPT tends to suggest things, but then that it can't actually do, right? Which is
you
a little
bit... You gotta shoot for the stars, though, right?
Yeah.
Like, you gotta continually better yourself.
Totally. But in this case, it seems to work. So, like, it's created this this contour map, or the shaded, whatever you want to call this, of this. So that's cool. That's great. That's great. Now,
But it's funny though, but that is, I guess, okay, maybe it's not a contour map.
Yeah.
Okay. Hey, you know what? Let's lean into that. That's good, but it's not technically a contour map.
Know your audience, right?
Yeah. Please make this as a contour map with contour lines. Oh, let's see if. No, can it do that? I don't know.
I wonder if we had to give it parameters of right. No,
There you
No,
go.
see? Better yourself.
Yeah,
I'm
there you go.
satisfied.
So, it's interesting, like, why would it assume you don't want the lines if you specified a contour map? I don't really know, but, like, good. As I say, kudos to you for not letting it off the hook. I'm even going to say that's better. This is the second surface.
But this is a good way, though, to test that it's doing it correctly, right? Because we're going to work under the assumption that you're not throwing data you don't know, or you haven't. If you're going to use generative AI to do calculations for yourself, you want a process developed.
Yeah.
So you'd want your balance and checks to know that the data's in and that you haven't reprojected it in a weird way. So doing a contour map is a good validation of, like, yes, my maximum is my maximum, my minimum is my minimum.
Yeah.
Actually, that's a really great point, because we had no guarantee that this read all the data.
For sure.
Right? So smart things to have done would have been to say, like, thanks, can you please tell me the maximum, minimum coordinate extents, right? Because then that's going to tell us, like, okay, does this fit? Like,
Does it stay within
I'm sure you didn't memorize this, but, like,
I did not.
but at least you could be like, okay,
But
great.
those look like the right
There's
ranges,
about 100 meters of data one way or the other.
Yeah, you're
and
not at
this,
sea level.
Yeah.
but I really think you're correct to say, like, okay, well, now make me a contour map.
Yeah.
You would, in the contour map that we saw here, this is kind of like smoothly varying. Okay, that's kind of what we saw in the data. If I said, now make me map of the second data.
I think that's important, though, because we use tools like AutoCAD where we were before, Lindy, and over time, especially in the engineering space, you create workflows where you develop trust with software.
Yeah.
So those balancing checks exist. And when you're new with software, you might go through 17 additional steps. And when you're senior with that software, you might kind of go from step 1 to 14 to 17. And you have that kind of gut check of this is how this works properly. So then if you're using new tools, you need to have those same checks.
Yeah,
Definitely.
For sure. Sorry, go ahead.
Even when you're using different parameters within your existing tools, you have to start doing those checks again and go back to the step 1 through 17. I think.
For sure. And this makes better sense for the 2013 because here now they've cut down, flattened it out. So I think that's a great way to check the validity of that data and make sure that what they're showing makes sense. So now the trick is, though, this data is not necessarily all the data that we care about. Can you now please show the 2013 LiDAR contours with the bound? Yeah, go
So
ahead.
these are already cropped.
These are they cropped strictly to 100 meters?
Yeah. So the source data, if you want, you can load those.
Except I don't have an XYZ.
Oh, fair. Yeah.
Which is fine, but let's try one thing here with the boundary in the provided shapefile overlaid onto the plot.
Yeah.
Right? And that's going to kind of simulate our situation here, because now what I want to see is I want to see the extents, like I want to see that drawn over top of it. Let's see what happens. I'm going to bet we're going to have a problem again with the projection where it's not smart enough to realize it's got a PRJ file. How Shapely Polygons handles the array I don't know.
That's correctly load. You're missing the DBF file. That could be possible.
DBF would be the... You're right, but usually I don't... Saying convert to GeoJSON... You convert the manual coordinates. Wait a sec. Let's try your point. Sorry. I missed the DBF file. I like how you're like, Rob, so polite. This is a chronic. Okay, let's see what happens now. Because it was able to read the thing
I
before.
read it before and it gave us corners. So.
Do they have shapely handles polygons?
There we go. Okay. It's done that with the crowd correctly overlaid in red. Oh, good old ChatGPT. There is no red.
It's taken all of the color out of it.
But there is no. Oh, you know what the problem is? Projection.
It's always projection.
Yeah. Using the correct projection for the shapefile.
I think what I'm really interested to, and this question popped in my head when we were doing with the coordinates and the reprojection on the boundaries, is like, okay, you get to lat and long and you're in decimal degrees, but then you go to DMS and you're like, I don't even know how to word that. How much does this store with it, right? Like, how far does it go? Because we always have the conversation in this space of, is it survey grade or GIS grade, or is it civil design grade, right? Like, how far will this take those decimals so that, from an accuracy point of view, like, where are we truncating it?
For sure. But we already saw with AutoCAD that, like, I thought it was interesting that the difference between doing it grid versus tin resulted in, like, what was it, like
24.
Yeah, right. And that,
in a dump truck, that's not a lot.
Exactly, right? So we're already dealing with these. This did this correctly, so now we've been able to plot this. Now let's say, can you calculate the total volume difference between the two surfaces? And I would normally say within the polygon, but you've said you've already...
Yeah.
Okay, let's see what's going to happen here. So again, it's popping open some sort of code here. It's doing something. It always kicks off an error. That's great. Then it's smart enough to start figuring, oh, look, total volume difference between the 2006 and 2013 is approximately 5127 cubic meters, right? And
it's pretty good.
What did AutoCAD give us?
That was
2130.
5106, and then it was 5130.
Yeah.
So it's closer to the grid than it is the 10.
Yeah, so like 5106. I'm blown away you folks remembered that through this whole thing. So interesting, like it actually calculated within our sort of engineering requirements the correct and then let's ask for
I'm happy and uncomfortable. Because that's wild. I want to know how I did it.
Okay, so let's ask it.
Like what method?
Can you outline how you did this calculation? Certainly. Right, so it cleaned the data, then it interpolated to a common grid, which I think is how AutoCAD does the grid-based thing. So it like set up a thing, then it just calculated the difference between the 2 points, and then said, well, I'm doing a 1 meter by 1 meter grid, and away you go. You could ask, one thing it doesn't say here, because I don't see, is what the spacing of the interpolation grid was. But
I wonder if it used the...
What was the...
Gridded, right?
Yeah, so I wonder if it... But they wouldn't have been gridded identically.
Yeah.
But I think you could also... so it created a regular grid by making a 300 by 300 grid. So, interesting. So it basically said, I'm going to have 300 points by 300 points. You got 100 meters by 100 meters
So
effectively.
It's
33 centimeters to smooth, which is actually tighter than what AutoCAD did in the thing. Now what I can do is I can say, can you please show the volume difference, or elevation difference, I guess, as a heat map. And, does that look about right?
Yeah.
Oh yeah, look, you get this little thingamabobber in there. Elevation. Now, did this mess this up? Was it?
It's got them backwards, yeah.
Ah. it's got it flipped around. Is that?
Yeah.
Because the berm is on the west side, right?
Yeah.
And it's saying the berm is negative elevation.
Yeah.
Which is not.
Wait a sec, but it's saying 2020,
Oh, but
20
it might be comparing them the wrong way.
2013 and 2016 areas in red represent elevation loss. So it said it cut and filled over to the side.
The berm is on
The berm is on the west. Yeah.
Let's take a look.
So, no.
So yeah, I think it's
Hold it. So it added.
I think it's using 2013 as the base. And
That's what I mean. I think
2006 is
the comparison.
the comparison. Yeah.
So you think it flipped it around?
Yeah.
Well, I think the math is right. It's just
Yeah.
it's OG surface, and I think that should be the next step is use the base.
Well, it says here that the 2013 is the second surface, and 2006 is the first surface.
But that question is how it calculated the volume difference, not how it made the heat map. So I could argue that.
But we are seeing, looking at this, we are seeing the blue fill along the very west edge on this. So maybe it's because of where we put the grid, the 100 by 100 grid.
Oh.
It's just catching the toe of that.
Or let's do it this way. Let's go to surface properties. Because we trust AutoCAD, right?
Yeah.
So we're going to say elevation banding 2D.
Yeah.
Right? So this is,
Okay.
if I hover, hover. So 1 meter of fill on that side. And then up in here, 2 meters of cut.
Yeah, so just before the berm.
Yeah, before that,
We hit,
before that berm, and that's about 1 meter of fill here and 2 meters of
Yeah.
cut.
So
But again, like this is a good sort of like, hey,
that check in.
how to check now. Like as the little, finale, what we could do is we could say, can you output this heat map as a patch that can be viewable in Google Earth. Right, so what I'd like to do is I'd like to export that as a thing that I could drop into Google Earth.
Yeah.
No, I don't want to do that. Nope. I would like it as a KMZ. I don't want TIFF.
I'm just telling you to do the work? No,
Yeah,
sir.
no. If you prefer I generate a properly georeference, please download PNG. No. I would like you to recalculate the heat map and do what is necessary
You're pleased and thank you,
create
Ryan.
a KMZ showing
Do what I told you to
its
do.
elevation difference. Let's see what happens now. I do notice that, like, it is pretty funny. Oh, thank
You.
It is like a lazy assistant.
it kind of tragically. Like sometimes.
I could do that, but here's how you do it if you want to do it yourself.
All right, let's see what happens here.
That's not my job right now.
Just the first.
There you go.
Yeah, that looks like the spot. Well, it's a little.
Well shifted, but I think that's just
That's actually the 100
Google
meter, yeah.
Earth thing. But like, it's coming in.
Yeah.
Like, there you go. Actually, though, you know what? It's flipped. I think. I don't know. It's a heat map, so
It is.
No, it's the right spot.
it's the right spot. But
But I
you
think
see
north
how
is
there's that
right.
little, this little
Yeah.
extender is actually south.
Yeah, like I think it's flipped.
Could be.
Could be.
Could be.
I don't know. Let's ask. Is the map flipped? Oops. South by any chance?
But when we look at the contours in CAD, we see that same.
Well, and actually, I guess it's not necessary that it is flipped because you're right. We're looking at elevation differences, so it really depends on what's going.
I just think it's interesting that when you questioned the Overlord, it was bolded no.
Well, I give it kudos on that because
This
usually
case,
it just
no.
flips on you, and it's like, oh yeah, sorry, whatever, yeah, it is flipped. Away you go here. I'm not, and it's saying like, yep.
However, to verify, I like that. Here's what you
Mismatch extents, ground overlay.
Yeah.
Yeah, no, that's and that does look like the calculation that it had off the hop. So I'm going to probably say that's right. So cool. So probably not replacing AutoCAD anytime soon, or you. Job safe. Well, actually, I would argue this is kind of an interesting point. Definitely not replacing the designer anytime
I'm
soon.
just like, well, actually, nothing.
because it goes to the point of how important it is to have some sort of concept of what is correct and incorrect, because otherwise you would argue that AutoCAD would have replaced designers long ago if all I have to know is like, okay, what's the... Actually, what's one of the kind of cool things before we close this thing off is one of the things you can do in ChatGPT or Copilot or Gemini, and actually let's give Gemini a little bit of equal time here, is you could actually say, if I have a LAS file of two surfaces and would like to compare their elevations in AutoCAD Civil 3D 2025, how would I go about doing that? Right? And one of the kind of handy applications is of ChatGPT is actually like a help file on steroids because it understands context, so you don't have to like Google like, hey, and then
97 blogs,
Yeah.
get into Reddit, go a deep dive.
Totally.
Yeah.
Right? Instead, you're like, okay, this is how you set your coordinate system. This is incorrect, though. I don't believe you can actually directly attach a LAS file. You have to go. Do you not have to create an RCS?
In 2025, I don't know. I'm still using 2020.
Okay. We don't hold that against you.
Yeah. So in 2020, you have to create a
go
recap
through that.
file.
So that'd be something to check. But it then does run you through like create surface from point cloud, et cetera, and how to actually do this, right?
Yeah.
So I find my favorite question of all time is like DIA command. Anyone remember?
I do.
There you go.
Yeah.
So, pro tip to everybody out there, if your dialog boxes are not showing, it's because your file DIA is set to 0.
Or your command DIA.
Or command DIA, that's right. We really need to do one of these just like...
Here are all the tips and tricks.
Tips and tricks of AutoCAD sessions. So, all right, well, cool. Thanks, everyone, for joining us. Hopefully you learned something about how to calculate volumes and use ChatGPT for some kind of more sophisticated engineering applications. And as always, remember to check your work. That's the whole trick here. But thanks to you two. Welcome to the session. We hope to see you again sooner than later. So, thanks, everybody. We'll see you later.